Hey guys, welcome back. So in today's lesson we're going to be talking about geometric series. In the last lesson we talked about what a geometric sequence was. In that geometric sequence you have a sequence of terms in a particular order, and between each of the terms there is a common ratio. So to go from the first term to the second term you multiply by a certain number, which is r. And then to go from the second to the third, you multiply the second term by r to get to the third term, and so on and so on. So in a series, you're going to be doing a similar process, except in the series, you're going to be finding the sum up to a certain value. So let's go ahead and dive right in. As always, make sure that you print these blank notes out from Google Classroom so you can fill them out as you go along. I'm going to be collecting your notes as a grade, so make sure you're doing that. You can also write these on a blank paper if you want, or use the Kami extension on your touchscreen computer to fill in the notes on electronically. You can either use a stylus to write those out, or you can use the text tool and type the notes in. The choice is yours. Whatever you do, make sure that you put your name and the topic. So this lesson is actually Unit H, and this is Lesson 5. And then the date, so it's Wednesday, April 15th, 2020. And don't forget to put your class period in there. All of this is just to make it a lot easier for me when I grade them, so please make sure that you're doing that. Let's just dive right in and talk about what the definition of a geometric series is. A geometric series is the sum of a geometric sequence. And to find the sum, you're going to use a very particular formula. We're going to go over what the formula is right now. The sum of a geometric series up to a particular term is going to be the first term. Now this is one big fraction, so leave yourself some room here. The first term on the top times 1 minus the common ratio to the power of n, and all of that is going to be divided by 1 minus r. Okay. Now, I know that so far you've had formulas in every topic that we've covered, so just bear in mind if you were to have any kind of test or anything on this, you'll have all the formulas so that you don't have to memorize them, but you will have to know how to choose the correct one to use, okay? Okay, so the n in this formula represents the number of terms. And A1 is the first term of the sequence, and R is the common ratio. Okay, so let's start out with an example problem here. We're going to look at number 1. The first thing we need to figure out, the first thing that you should be looking at is the directions, which is find the indicated sum for each series. So we're going to use our sum formula here at the top. So what are the things that we're going to need to plug into this formula? Well, we're going to need to know what number term we're supposed to go up to find the sum. We also need to know what is the first term of the sequence, and we need to know what r is. And this is an n up here, so if we know what number we're supposed to go up to, then naturally we already know what n is as well. Okay. So the first thing I can pull out is that because I'm supposed to go up to the 14th term, I know that n is going to be 14. I know that the first term in the sequence is 4, so a sub 1 is 4. And then I need to figure out what is the r value, which is the common ratio. So what am I multiplying a term by to find the next term? So 4 times what gives me 20? Well, 4 times 5 gives me 20. And 20 times what gives me 100? Well, that's also 5. And then 100 times what gives me 500? It's 5. So you're multiplying by positive 5 each time. Now, the second step here is going to be to use the formula to find the sum. We're going from the first term up to the 14th term. So the sum up to the 14th term is equal to, I'm going to make a big fraction here. It's going to be, if we follow our formula, the first term in the series, which is 4, so 4 times the quantity, 1 minus r. Well, we know what r is, it's 5, so let me actually just fix that. It's a 5. And that 5 is going to be to the power of n, and n is 14 because we're going to the 14th term, so 14. And then in the denominator, you just have 1 minus r, and r is 5, so 1 minus 5. So let's use our calculator to fill this in. We still have our big fraction. The denominator is super easy. It's just 1 minus 5, which is negative 4. And then the numerator, we're going to do the inside of the parentheses first. That's going to be 5 to the 14th power. And you take 1 minus whatever that is, it's a huge number, and multiply that by 4. Okay, so I have a choice. I could write all of this out on my paper, or I could just use my calculator to solve it for me, because I know I'm going to be dividing it by negative 4 anyway. So I'm going to just go ahead and put negative 2.44 ... times 10 to the 10th power. That's what the e means, because we have a super large number on the top. So I'm just going to use my calculator to solve this, divide it by negative 4, and I get a somewhat smaller large number. So it's 61035155624, and then every 3 spaces we put our commas. Okay, so it's gigantic, and that's just lovely. So yeah, that's the sum of this series. And if you think about it, does that make sense logically? So we're going from 4 and we jump all the way to 20, and 20 jumps all the way to 100, and 100 jumps all the way to 500. 500 is going to jump all the way to 2,500. So I think it makes sense that we would end up with a large number like this, because when you add up all those 14 terms in the beginning of this series sequence, then you're going to have a huge number. Okay, so let's look at number 2 and let's solve that one. In number 2, we have a series that looks like it's getting smaller. We know we're going up to the 20th term, and all we really need to figure out here is what is going to be the value of r. We know our n is 20 because we're going to the 20th term. This is n right here. And then we know the first term in this series is 81. So what is r? What's happening with r? Well, remember in the last lesson, I taught you guys an easy trick to find the r when the series is getting smaller or the sequence is getting smaller, because you're multiplying by a fraction and it might not be as obvious exactly what's happening or what's changing about the values. So if you go from right to left and you divide, then you can find the r value. So 3 divided by 9 is going to give me 0.33333, which is a third. And 9 divided by 27 is going to give me also 0.33333, and it's going to be a third. 27 divided by 81, whoops, 27 divided by 81, let me type all the numbers. It's 0.3333, and it gives me a third again. So the r value is safe to say is a third. I don't need to worry about plus and minus because none of these terms are negative. It's not switching signs every time on me or something. So now that we have these 3 pieces of information, we just plug them into our formula and we'll go ahead and get an answer. So let's pull this out and let's do S20. We're going to have a big fraction. The first term is 81. We're multiplying that by the value of 1 minus r to the nth power. So r is 1/3. And that's to the power of n, which is 20. And the denominator is just 1 minus r, which is 1/3. Okay, so doing this by hand is not something I would recommend to you. I would recommend that you use a graphing calculator. If you don't have one at home, you can pull up Desmos Scientific Calculator online, and you can go ahead and use that to go ahead and calculate it for you. So let's work from the inside out. So we take 1/3, we bring that to the power of 20, we do 1 minus that answer, we multiply that by 81, and then we're dividing that by 1 minus 1/3, which is negative 2/3. And 1 minus answer, 1/3 to the 20th, times 81. Okay, I tripped myself up for a second and just figured out what I did wrong. So if I look at my calculator, I did 1 minus a third is negative 2/3. That's wrong. I don't know what I was thinking. It's just 2/3. So it's actually going to be the same exact answer except positive, and that's what I was tripped up about, because this is never going to be negative. It's just going to be smaller and smaller and smaller positive numbers. So if I add up all those positive numbers, there's no way I would ever end up with negative 121.5. The answer actually is 121.5 positive. Okay. Box my answer, good to go. All right, so we're going to flip that over, and there's a couple more example problems on the first page. I'm going to leave 3 and 4 for you. 3 and 4. I'm also going to leave 7 and 8 for you, and we're going to do 5 and 6 together. Okay. So let's jump into these examples. In number 5, this is in sigma notation, so remember the difference here. Okay. In sigma notation, they don't give you any of the terms in the sequence. They just give you the rule. So if I were to take this 2 to the power of n minus 1 right here, this is the rule for the series. It's how you could find any particular term of the series. You just take 2 to the power of n minus 1. And what the sigma is telling us is that we're going to start when n is 1, so the first term, and we're going to go all the way up to the 25th term. Okay, so we have everything that we need actually to do this problem. So the first term is 1. Now, how did I know just by looking at this that the first term is 1? Well, if you recap from what we did in our last lesson, I'm going to write this in the margin, okay? The rule for geometric sequences was to find any term, you would take the first term in the sequence times r to the power of n minus 1. Well, if this is our rule, then the only thing that's missing would be the a1, or the value that would be in front of here, multiplied by this to the power of n minus 1. So the only logical solution would be that the first term is just 1. And actually, if you take a look at problem number 6, there is a number being multiplied by the thing that's being raised to the power. So in this example, it's more clear what the first term is. This one, you don't normally write 1 times something. You can omit that. That's why it's not written there. So the first term is 1. And then if we follow that same scheme here, the thing that's being raised to the power of n minus 1 is going to be the value of r. So in this case, the r is 2. And then the only other thing we need to find for this series is we need to know to what term do we go up to, and that's going to be the 25th term, because we're starting at 1 and going to 25. Okay, so same as the other problems that we've been doing. Now that we've got these 3 pieces of information, we can go ahead and just use the formula. So the formula tells us to find this summation. We're going to be taking this big fraction. That's going to be calculated by doing the first term, which is 1, times the value of 1 minus, and that's going to be r, which is 2, and that's going to be to the power of the n. N is what we're going up to, which is 25. And then in the denominator, you just do 1 minus r, which is going to be 1 minus 2. So we can use our calculator to solve this for us. We do the inside first, 2 to the 25th power, 1 minus that value, and then you multiply that by 1. Well, that's itself. In the denominator, you have 1 minus 2, which is negative 1, so you're dividing by negative 1. So my summation for this is going to be 3, 3, 5, 5, 4, 4, 3, 1. Bam. Okay. So let's box our answer here, and then we'll try the next problem. We're going to actually do number 6. So let's do number 6. And in number 6, we're going from the first term up to the 8th term. So the n here is 8. This right here, all of this, looks just like the rule for the sequence. The first term is negative 32, so let's go ahead and fill that in. And then the r value is whatever the thing is that's being raised to the exponent. So the r is negative 1/2. And that's it. That's all we need in order to solve this. So our summation for this is going to be, let's make a big fraction. On the top, it's the first term times 1 minus r is negative 1/2. Oop, I need more space. That's going to be to the power of n is 8. And on the denominator, it's going to be 1 minus, and r, I'm doing parentheses here because the r is negative and I just don't want to mess up my signs. So 1 minus r, and r is negative 1/2. You know that's going to be a plus, but I'm just writing it out so I don't mess my signs up. Okay, so we need to do some simplifying here. So let's figure out this inside part first. This is going to be negative 1/2 raised to the power of 8. And I'm not even going to write that down because it's some crazy decimal. It's 1 minus that answer, that's the inside, and then you're multiplying that by negative 32. So our numerator is negative 31.875. And our denominator is going to be 1 plus 1/2, which is 1.5. Okay, so let's go ahead and do this math. So we're going to divide this by 1.5, and we get negative 21.25. Now you might be questioning yourself now, well, is it okay that the answer for this series is a negative number? And the answer to that question is yes. And the reason I know it's okay is because I started with negative 32. The first term in that series is negative 32. My r value is negative 1/2. So what's happening is when I find my second term, I'm going to multiply these together. Negative 32 times negative 1/2. That's a positive value, and 1/2 of 32 is 16, so negative 32 plus 16. But then when I find the next value, it's going to be 16 times negative 1/2, which is negative 8. So if I start adding those together, plus 16 minus 8, I get negative 24. And then it's going to just keep kind of changing from positive to negative as I go along in that series. And then up to the 8th term, when you add everything together, it's going to give me negative 21.25. Okay, so that's going to go ahead and be it for this lesson. We went over today, I'm going to unfold my page so you can see everything. We went over today geometric series, what the formula is to find that sum up to a particular number term in the series. And we did 2 types of examples. We did when they give you some of the terms, and we also did some that were in sigma notation. So remember, I'm grading you guys on the quality of the notes that you submit, which is going to be everything we wrote together today in this video. And then I'm also going to give you points for completing the practice problems, which are 3, 4, 7, and 8. And you can submit those on Google Classroom. If you guys need any help at all with anything that we did in this video or anything we've done so far, feel free to pop into my office hours. Those are on Tuesdays and Thursdays from 10:30 to 1:30. Okay guys, I will see you guys next time. Thank you for tuning in.